All right, so example 2 is about combining those terms. So when we find like terms, what do we do with them? We're going to combine them. So I'm going to go back to that problem that we did just a few minutes ago. Okay, and if you want to just make sure that you're continuing on that last example, this is exactly what we had written on that previous page. Okay, exactly what we wrote down. So when we want to combine like terms, basically what we do is we take our original expression and all of our terms from it and reorder them so that the like terms are next to each other. So I'm going to start with my x's. Okay, I know that 3x is positive, so my new expression is going to be 3x plus 2x, okay, because I moved these two terms so that they were next to each other. And then my other like terms, which are 9 and negative 5, I'm going to move them next to each other, plus 9 minus 5. Because remember, if I have a negative number, it's basically just subtraction, okay? I've rewritten this expression so that my like terms are next to each other. I did this using commutative property. Remember when we talked about commutative property? It basically says that you can move the numbers or the terms in an expression so that they're next to each other or so that different numbers are next to each other. So all I did was I moved this 2 so that it was here, and I moved this 9 so that it was here. Okay, that's all. I just flipped their places. All right, and now that I have these terms together, I can combine my like terms. I know that these are like terms because they have the same variable. So 3x plus 2x is 5x. Okay. And then I know that these two are like terms because they have no variable. And positive 9 minus 5, or 9 minus 5, is 4. Okay. Since 4 is positive, I put a plus in between. If 4 was negative, I would put a subtraction sign, but it's not. So this is my simplified expression. I cannot simplify it any further. I cannot combine that 5x and that 4 because they're different terms. They're not like terms. 5x is basically like a fork, and 4 is like bananas. I have 5 forks and 4 bananas. I can't combine them to have 9 bananas. That would be ridiculous. Or 9 forks, because they're completely different items. They're not the same. Let's try another one. All right, I have y plus y plus y. So let's start by identifying terms. Y is a term. That's that first one. Y is a term. That's that second one. And y is a term. That's that third one. I know that it seems kind of weird because they're all exactly the same, but I do have to write all 3 of them. Because when I start writing like terms, I want to know how many like terms I have. Okay? I have this y. I have this second y. And I have this third y. Okay? Now notice that in front of my y's, I left a little bit of space because I want to remember that when you don't have a coefficient, no coefficient, then your coefficient is a 1. Then there's an invisible number 1. So this is 1y, 1y, and 1y. They're all positive because in between our addition signs, I don't have any negatives or any subtraction signs. Okay, so then when I rewrite the expression, I have y plus y plus y, 1y plus 1y plus 1y, which will give me 3 y's. And that's my simplified expression. That's as far as it goes. I can't simplify it any further because I don't know the value of y. Okay, so in the left, we've written down some things that we already knew that we just needed to remind ourselves of. Let's do another example. Okay, this example is going to take into account some things that we've previously learned. So let's remember that right next to this 2 is a multiplication sign. Next to this next to this 5y is a multiplication sign, and hiding next to the z is a number 1. Okay, so now I'm going to write out the terms. Actually, what I'm going to do first is distribute. So I've got 7z stays the same, plus 2 times 1z is 2z's, minus 2 times 5y is 10y's. Okay, and now I can use just boxes to find my like terms. 7z is like 2z because they both have z's, and